Hello, my name is Natalie Plata, and today I'll be addressing the socio-technical gap in engineering education. So a little bit of background information on our research. Our research focuses on bridging the socio-technical gap between the technical and non-technical perspectives to better prepare engineering students for the real world. So engineering education has taught most undergraduate engineering students to use their technical skills to solve a complex problem. So oftentimes, regardless of which type of path a student has taken, whether it's chemical, mechanical, electrical, and so forth, we are taught to we are given a problem and we are taught to solve that problem, oftentimes by means of mathematical analyses, some type of conceptual or numerical analyses, or a combination of both. But oftentimes it's very, unfortunately, linear path. And so engineering education has taught most undergraduate engineering students to use those technical skills to solve these complex problems. However, students oftentimes don't realize that a problem involves, well, problem-relevant social dimensions, which are related to community, environmental, ethical, economic, and other perspectives. These other views are seen as non-technical and oftentimes are pretty much disregarded in engineering education. So our research focuses on bridging that gap between the technical, what we know as quote unquote solving complex problems via this numerical method or analyses, as well as combining it or bridging it with the non-technical dimensions, which include the community, environmental, ethical, economic, etc., in order to better prepare engineering students for real-world problem solving. So there are 5 different data sources that our research has focused on. This includes focus groups, both pre and post survey data, interview assignment, and faculty reflection logs. So we have both student and faculty data sources and where we examine and analyze each one, and we try to figure out what anchors, in this case anchors are real world examples, as well as what perspectives or what are the things that both students and faculty have to say about engineering education and about socio-technical integration as a whole. And what some of the preliminary findings have been that these anchors or these real-world examples really do strengthen the ST or the socio-technical integration. Other things that, or other preliminary findings have been timing. Timing is actually very, very important when we're talking about ST integration. Whether we discuss the socio-technical integration earlier in the year, so this would be like first, second year students, or later on, maybe third, fourth year students. This is a topic that is again, preliminary findings, so it's still a topic that we're still discussing. Repetition is another one. We've noticed that the more a student is shown socio-technical integration, real-world examples, different problems with different solutions, we've noticed that the way that a student views the problem becomes more rounded, whereas if you just give a student maybe a function or something, they're going to look at it very linearly. So these ST integrations, as we like to call them, with repetition or more real-world examples, they do tend to expand the horizon of the student. And surprisingly, accountability. There has been some preliminary findings where students feel more comfortable, um, and I would also say it also expands their mind when they have, for example, in design courses or in earlier courses, where they have a certain stakeholder where they constantly have to talk to or have to be accountable for whatever it is that they are researching. So that accountability also helps with that ST integration. So the importance of these anchors. Before we get to that, like I said, we were going to discuss a little bit of these real-world examples. Here are 4 listed, and you can find other material and resources on the website below. Some of the examples that were given, and especially this one right here, the interview assignment, is very, very important because we've noticed that this is one of the assignments where students actually were able to grasp and be better able to bridge that technical and non-technical aspect. And so this assignment asks students to interview both an engineer and non-engineer, and it gives you different prompts. What are their age range? What are their responses for their gender? Their expertise. Why would they solve the problem that they have? So for example, if a student is doing a project on building something and they have to interview maybe both an engineer and non-engineer, how would they respond? What resources are needed to solve the problem, including the people with specific skills or expertise and or experiences? um, and what would a solution look like? And so asking these questions to both the engineer and the non-engineer actually expands their horizon and makes a lot of students realize that, again, these problems are not one-dimensional, but rather multidimensional. Um, and the reason this is so important, not just to students themselves, but also to educators, is because it also helps educators give students the tools to break the preconceived engineering problem-solving habits that students have and basically foreground the multidimensional components of a problem. So what do future research steps look like for our team? Based on our findings, our team will be conducting cross-cutting analyses between all data sources. This is going to include course, semester, and year. We will be addressing pre-existing questions that we had in the beginning, as well as discuss what new questions were generated from our data. Again, the research that we're doing, we're still analyzing, we're still trying to figure the best way to address this socio-technical gap. Obviously, based on findings, questions may change. Questions may morph into either other questions or other answers that might be combined with other questions. So it's always an ongoing process. I would like to actually thank everyone on my team, as you can see here in the pictures, and also NSF for being a sponsor or basically funding this research. Thank you.